Okay, welcome back to AET 830. So in this video, we'll continue with our discussion for unit number 1. So in this video, let's talk about the evolving of Internet of Things. So first of all, and also after this class, you should have an idea that the Internet of Things is not a single new technology or phenomenon. Okay, the keyword here is single. I would say the keyword is not a single. Okay, so it is a set of technologies that combine, deliver the promise of Internet of Things, IoT. So if we look back to the definition of IoT, we talk about connecting computers and mobile devices. It is not new, right? Nowadays we have, well, not nowadays, maybe 10 years ago we are already doing this. And also, building sensor networks are not new. So it has been there, maybe back to the 1990s and 2000, something like that. So IoT can be viewed as a coming together of a set of different technology disciplines of usage. Basically, IoT is a combination of technologies. That's something you should have in mind. So what are the elements of IoT? Or we'll say enablers. So IoT as a concept of sharing data and information about things and machines using devices and systems can be unfolded into a family of technologies and practices. So basically, basic technologies means that we have the technology backbone. Those are the enablers. And practices, those are what we have been doing. Basically, those are the motivators or the current status. So this figure actually shows many members of the family. Of course, I don't think it is complete. So this is a family of both close and distant relatives. So coming from different generations and all having the same meaning in life. The meaning of interacting with the physical reality in different ways. So for this family of members, we can see M2M. M2M stands for machine-to-machine communication, and also big data, machine intelligence, artificial intelligence. So for the next 2 slides, so now you see they are italic, right? So what does electric mean? So basically it means that you can read it yourself. Basically these 2 slides give some description of the terminology mentioned here, including big data, embedded systems. So basically it helps you to understand these items. But the whole idea here so far is just to understand that IoT is not a single new technology. It's a set of technologies and practices put in together. Okay, so with that in mind, let's have a brief background of IoT. Really brief. So the IoT is a result of technological progress over the last decades. So the progress includes TCP/IP protocol. Yeah, if you don't know what they are, we'll cover them later in this class. Semiconductor technology, basically those are the chips. Nowadays, the chips. Okay, the chips are not the potato chips. Okay, it's electronic chips. So they are getting smaller and faster and cheaper. So basically they are the technology backbone for the IoT. And also now we have reliable and fast mobile networks. And the sensors, electronic tags, and actuators are also coming in different sizes, capabilities, and with lower price. So those are the technological progress over the last decades. So they are all important factors for the birth of IoT. You can imagine that if a sensor is costing 200,000, sorry, it's too big, 2,000. So it will not be possible to deploy a large number of sensors. But if a sensor is maybe $20 each, so you can see that you can just put it everywhere and collect data. So those are the enablers for the IoT. With that technology progress, there are threefold reasons for the dramatic increase of the uptake of IoT solutions. So these are the 3 reasons why IoT solutions are coming out in recent years very fast. So first of all, there is an increased need for understanding physical environments in its various forms. Basically, we want to know the environment. Now, of course, the purpose is to help our people live better, right? But we need to understand the environment, know about them by collecting data, right? And the next reason is the availability of technologies and services to more cheaply collect and analyze data. So that's what we mentioned just now. The sensors, the tags, the actuators, the processors, the chips are more affordable and capable now. With that in mind, and with these 2 reasons, the next reason is the reduced cost of components for IoT devices with sensing and computing capabilities. So that's an extension of the second reason. So it is computational and sensing capable. So those are the boosters for the dramatic increase of IoT solutions. Okay, so we mentioned IoT solution just now. So how a IoT solution look like? So in this case, we'll just use a simple enterprise IoT solution to give an idea. So it is the solution here is just to remotely monitor and control enterprise assets. For example, you have in Walmart, so you have many shopping carts there, right? So maybe you have noticed the shopping carts may be damaged, may be stolen, or maybe put somewhere secretly in the parking lot. So basically, the Walmart want to remotely monitor and control the carts. For example, shopping carts. So this is an illustration of a simple IoT solution. So there are 0 elements. Actually, there are only 4 elements. So the asset, in this case, it will be the what? It will be the shopping cart, right? First thing we need is IoT device. Basically, those will be sensors, which can know whether the cart is in the store, for example. And then the information or the data need to be transferred using the network. So in this case, it may be Wi-Fi, it may be cellular, depends. And then it will be uploaded in an IoT platform. IoT platform just as it is just like an ecosystem where the IoT application will be developed and will be developed and will be working on. And based on the information collected, and for the IoT application here, so it may include, in this case, it may include the location of the cars, right? But for the enterprise, for the Walmart, it may also develop an upper level application that makes use of the IoT application information, for example, the location of the cars, to make further improvement. For example, they may develop for the enterprise application, they may have a maintenance schedule, or they may have a reorder schedule for missing or damaged shopping carts. So in the next 2 slides, we just highlight the key elements here. The IoT device, it is the asset of interest is instrumented with the IoT device, provides sensing and actuating capabilities. In the previous example, it is just sensing the location of the carts. If we want to actuate means it do something. We may add a loudspeaker on the cars. So if it is taken out of the area of the Walmart, it may just give an alarm, right? So those are IoT device. And then we need the network. The purpose of network is to provide more connectivity between IoT device and the application backend and enterprise IT system. Basically, the data need to go through the network. And for the IoT platform, you can consider as at this moment you can consider to be operating system. For example, the Windows, iOS, those things. Basically, they provide genetic functionality that is common across a number of different applications. So for example, if you had a Windows system, then you can develop different software on using the functions provided by Windows, right? So in that case, the software you develop in this case is the IoT application. Basically, you can at this moment you can think about IoT application platform is the Windows, and IoT application is a software running in the Windows, and it is developed based on Windows functions. So in that case, the IoT application is quite specific to the application. In this case, it is monitoring and control process of the assets. So those are the basic elements. For more complicated applications, so there may be more elements, but we'll go through them when the time comes. Okay, at this moment, I just don't want to get you too confused. But I hope that this flow chart here shows the whole process for the IoT solution. Currently, the IoT solution covers numerous industrial factors. So we have connected cars, utility industry, healthcare, and logistics sectors. You can go to the textbook to read the more details on these examples. So because by the end of the day, we'll come to detail for these applications in later chapters. So for this moment, so I will just leave this reading to you. So when we come back to the original question, so we mentioned that IoT is a set of technologies and practices coming together. So you may ask, what is new related to IoT? So here is a summary of the key points. So you see there are many red fonts, right? So those are the key information you should try to understand and grasp. Yeah, so some of them may be too technical for you at this moment, but if you can keep them in mind, and later on when we move into more technical items and you come back to this slide, you will have a feeling of, oh, yes, it is something like that. But for now, I will try my best to explain what they mean. So for IoT, it is new because of the use of open and standardized Internet and web technologies instead of industry-specific technologies. Basically, previously, many companies are developing their own technology and they are not interoperable. Basically, a company cannot use the function, the technologies in B company. So that's not the case under the IoT in a scenario. And also, IoT will use the internet itself as infrastructure instead of separate deployed network infrastructure. If it is internet, that means basically everyone can access, and also every sensors, every actuators can be easily incorporated in using the internet. For IoT, it will be a common fabric of missing devices, data, and applications. So it is fabric. So it is more complex than the previous deployment. So it has rich and complexity in applications. So yeah, nowadays, the only limitation is your imagination for the applications and the interconnectedness of IoT systems. Basically, it is not the sensors, the actuators, and the apps are connected. So basically, different solutions can also be connected to reach a higher target. So we talk about this maybe in an example later in this chapter, but you will know that. And also the collaboration and joint innovation of all engaged stakeholders. So basically, because the data need to can come from different stakeholders, basically that will enable collaboration and joint innovation. With the understanding of this slide in mind, so the IoT is not an internet; it is an extension to the existing internet. Basically, it includes all real-world assets as intelligent creatures, exchanging information, interacting with people, and supporting business process. So that's a description of the relationship between internet and IoT. So it is an extension. Why it is an extension? Because for IoT, we need to use Internet of Things. We need to use internet as the infrastructure. The IoT is also about how data from many different devices can be shared and integrated into numerous applications. So instead of close off one device, one application to solve a point problem, the IoT is about an open-ended multiplicity, many devices, many applications, as indicated in this figure. So for the one device application scenario, for example, if you want to monitor your heart rate, for example, so you may need a device. Basically, you may need a sensor that can measure heart rate, and then the application is to know your heart rate, right? But that's the one device, one application scenario. But for IoT, it is promoting many devices, many applications. For example, you have a heart rate sensor to measure heart rate. You have a temperature sensor to measure your temperature. You have a vibrator or activity sensor to measure your movement. And you have many other sensors and also other information inputs. Okay, that's one end. For applications, you not only measure your heart rate or measure your health status, also you can, based on the sensor information of your heart rate, your activity, your body temperature, those things, we can also develop applications for health diet. And also we can develop social network applications for helping you to know more friends with your life habits, something like that. So in this case, we have multiple sensors. And based on these multiple sensors, we come up with multiple applications. So it is not just like using a heart rate sensor to measure a heart rate. So not that case. In that case, so with the description here, you may also notice that there are many innovation opportunities here. Basically, you will find, so your job here is to find out the innovative applications of the data and information to help people in unknown ways, at least unknown at this moment. Okay, so just now, something to follow up. So IoT application not only rely on data from sensor and actuators. Equally important is blending of other information sources. Basically, they together can provide the contextual information. So sensors and actuators are very important, but other information is also needed because they will help you to understand what's going on under what circumstances. Some contextual information include geographic information systems. For example, if you basically when you try to use for example, when you are high in the mountain, right, a sensor may feel that your body temperature is low, right? But if it detects that you are at a very high mountain, so the low temperature can be explained. In that case, the sensor, then the app will know that, okay, you are still within the reasonable body temperature range. So they get my point. And also, the social media can also provide contextual information. So more examples can be found in the textbook. So with that, with all kinds of sensors, actuators, and contextual information in mind, one easily foresees emerging application domains that are driven from very diverse needs from cross industry, society, and people. And that can be of local interest and global interest. So for example, for the consumers, so the applications may come from the connected gadgets, the appliance, wearables, domestic robots, So I have been looking forward to a cooking robot. Yeah, hopefully it will come out very soon. And another example is for the environmental, right? So for example, we need sensors to monitor the pollutions, and also we want to monitor the air, water, soil status. So those are the diverse needs in different settings. You see there are 10, okay, close settings. So for the next few slides, actually cover some diverse needs in these areas. So for example, this covers the urban agriculture. So they are quite straightforward, so I will leave them to you. Because this is a graduate level course, so in the lectures, I will try to highlight the key points and help you to understand the logic of the items. But for some detailed reading, I will leave it to you. So also, after you read those examples, you can see that IoT can target very point and close, domain-oriented applications, as well as open and innovation-driven applications, enabling new business models. It can cover the entire value chain. It will handle both B2B and B2C business. So B2B means the two companies are interacting with each other. B2C means that the company is interacting with the customer directly. Basically, they are selling items to you, for example, directly.